welcome to the Journey Shake Cam. Today is such an exciting day. I get so excited when we have lab. So do those 2 warm-up questions to the best of your ability, and I'll see you in a moment. In number 1, we are determining the volume of hydrogen that was collected over water at standard temperature and pressure. And therefore, my initial volume given in the problem was 28.5 milliliters. My P1 is the pressure of the dry gas. Now, to determine the pressure of the dry gas, we're going to take the initial pressure that the gas was collected and subtract the pressure of the water at that temperature. And that would be 3.0 kPa. And therefore, 85.95 kPa is my pressure of the hydrogen gas without the water. My initial temperature is 24 degrees Celsius, and I must change it to Kelvin, and therefore my initial temperature is 297 Kelvin. I'm changing these values to standard pressure and temperature, and therefore this would be my chart of variables. Now, I know when I have volume, pressure, and temperature, I'm going to use the combined gas law, which is V1 P1 over T1 equals V2 P2 over T2. Therefore, I rearrange for my variable that I'm looking for. My unknown is V2, and V2 equals V1 P1 over T1. To undo my second temperature, I multiply. And to undo my P2, I have to divide. Then I just substitute in the values. And I get 28.5 milliliters times 85.95 kPa. And my T2 is standard temperature divided by my T1, which is 297 Kelvin, and my P2 is standard pressure in kPa. Now, when I solve this mathematically, I get 22.2273. Then I look back to my original problem and I see that my answer needs 2 significant digits. And therefore, this 2 does not round the 2 up, and my final answer is 22 milliliters of hydrogen. And it does not ask for another unit for my final answer, so I don't have any conversions this time. Now, this is what we are very similarly going to be doing in the lab today. I can't wait to get there, you know that. And so let's discuss a little bit about the values that will be taken in the lab. And I'll be right back. Number 2 is asking for what values we are going to record in the lab today. And what is a eudiometer? Well, a eudiometer is a gas collecting tube, and this is what we'll be using in the lab, and we'll see it a little bit closer when we get to the lab. Now, we have talked about this collecting over water once before, and let's review a little bit about what we're going to be doing. We are going to be taking magnesium ribbon and adding hydrochloric acid. We've had this type of reaction before. A element plus a compound is a single displacement, and the magnesium will displace the hydrogen, and we know we're going to be collecting hydrogen gas, but let's see where it comes from. We get magnesium chloride, and as always, we have to balance our compound. Magnesium is +2, and chlorine is -1, and that's why I need 2 chlorines to get +2 and -2, because compounds are always 0. And then I get my hydrogen gas, which is what I am looking for. Now, yes, the hydrochloric acid is in an aqueous solution and there is water there, but that is not what's involved in the reaction. We are going to measure the mass of the magnesium, and later we will be able to determine by mass volume. You'll notice in the data table it says 1, 2, 3, 4 And those correspond to the questions in the conclusions 1, 2, 3, 4, which tells us what we will be doing. And in number 1, we will be determining the pressure of the dry gas. In number 2, we will be determining very similarly to what we did in the warm-up today. Number 3, we are doing a mass volume problem where we would take the mass of our magnesium and figure out theoretically what volume of hydrogen we should be able to collect. And then we'll do percent error. We've done percent error before. And those 4 things we'll be doing in the lab. And we were going to be having a beaker of water, and we'll have the magnesium there, and then we will put our eudiometer, woo, I know you love my pictures, over that magnesium. We'll get the initial value, the initial volume, and the final volume, and that difference will be the volume of hydrogen, and we need the temperature of this water. And we need the barometric pressure, which would be our total pressure. We need the temperature of this water at which we're collecting that hydrogen. We need the volume of the hydrogen collected. And we need the mass of the magnesium. And we'll be doing that in just a moment. And I'll see you in the lab. Here we go, we're in the lab. I could just do the jiggity jig. I get so excited. But anyway, the first thing we need to do is measure the mass of the magnesium. I'm going to measure out 2 centimeters. And here we have 2 centimeters. And I realize that it's upside down. However, magnesium is so soft, I can just tear it. I will tear the magnesium. Now, this lab is not going to be great on accuracy, therefore I'm just do the best that I can and we'll go with the numbers that we have. Now, this scale will only measure to the hundredths place, and this may have been more accurate, well, it would have been more accurate if I had used an analytical scale that has more decimal places. But for our purposes, this will be just fine. And the mass of the magnesium is 0.03 grams. 0.03 grams. Now I'm going to take my magnesium and roll it into a ball. I'm rolling it into a little ball. And now I'm going to take it over to the lab station, and I'll see you there. This is so much fun. Well, I take my eudiometer and I'm going to practice doing this with just water first so that I know how it's going to work out for when I do it with the acid. So I'm going to pour some water from this beaker and I'm going to fill this tube all the way up to the top because I want to start with it all the way to the top and see how that works, see what my technique is. And I'm going to flip it upside down and put it inside, and then there's an air bubble here and my volume is about 4.5 milliliters here. I'd like it to go up a little bit more, so I will try it one more time. I don't have to worry about taking the water out because I'm just going to put more water in. And I did have it all the way up, so I will practice this one more time. And students always get worried about this, but you just try it. What could go wrong? Worst thing is you maybe could break the eudiometer, I suppose, but it's replaceable. Now I'm going to quickly invert it again and see, and I seem to be consistent, and my volume is even less, but that will work for our purposes. And then I'm ready. I'm going to pour all this water out. I am going to take the temperature of my water that I'm going to use to collect this over water. I'm going to take its temperature. Give it a second to get to the temperature. And it seems to be 26.0 degrees Celsius. 26.0 degrees Celsius. Now I'm going to take the magnesium that I have and I am going to throw it into here because I want to break that surface tension. Just like if I was diving off a diving board. I'm going to break the surface tension, and it went to the side of the beaker, but that's okay. I can still get it. Or I can actually move it to the center with my thermometer. But I don't worry too much about that. Now I will take my eudiometer and I will add 10 milliliters of the hydrochloric acid into a graduated cylinder. And I will measure out 10 milliliters of my hydrochloric acid. And remember, the bottom of the meniscus should be at the top of that line for 10 milliliters. Now, it's not extremely necessary that it be exactly. So if we had excess, we never pour it back into the original container. It would contaminate things, or it could potentially contaminate the liquid. And this would be fine though. So I will take my eudiometer and I will pour my 10 milliliters of my 3.0 molar concentration of my hydrochloric acid. And we're going to learn what molarity means. But for now, it just tells us the concentration, and that's all we need to know. Then I will pour the remainder in for water. Slowly, so I don't mix that hydrochloric acid there in the bottom. I want it to stay on the bottom. And remember, I poured it all the way to the top because it seemed to have a bigger bubble there. Now, sometimes we could use our finger to hold it, but I'm not going to worry too much. I'm just going to quickly invert it. We see that it's up here. I'm not taking the volume here. I take the volume after I've turned it upside down. So are you ready? On your mark, get set, go. And I go quickly and I put it over top of the magnesium, and then I get my initial volume. And my initial volume will be 6.6 milliliters is my initial volume. 6.6 milliliters. Now I'm going to wait, and possibly if we get up close, you can see that hydrochloric acid moving down that eudiometer until it reaches that magnesium. Moves down, down, down. But it gets pretty exciting once it reaches that magnesium. Here we go. I see the magnesium bubbling a little bit. Those bubbles, of course, go all around, and there comes the magnesium, up, 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 up to the top. As it gets closer to the top, there's more and more acid. Look at those bubbles. Wow, that's quite the reaction there, collecting this hydrogen gas over water. We like having a cow. It's some fun. And I just have to be patient now as it continues to react and bubble there. We're collecting the hydrogen over water because there's water in the beaker, and we have our initial volume of the hydrogen. We need to get our final volume of the hydrogen. And then we just need the barometric pressure. So that's pretty much fun. Patience. We're learning about that patience again. Here we go. Now we'll just wait together on this one because it's very interesting how this works. That hydrogen is forming those bubbles. Show me that there's a gas forming here. We want the magnesium to be completely dissolved. The reaction to be complete. Sometimes it takes longer than other times. But the bottom line is we just have to be patient. Wow. And I can see that the volume is going down, down, down. I'm getting more and more of that hydrogen gas being collected here. Got a little bit ways to go here. I can see that piece of magnesium dancing around. Now, it is possible to set this up with lab equipment so that I would have a ring stand holding this eudiometer. But I find that it works just fine being like this, and then I can do it a lot more quickly than having to attach it to the ring stand. I prefer to do it this way. And we know that there's always more than one way to do something. We all have our own unique ways of doing things. And I see I just have a little tiny piece bubbling away. One little piece broke off. Almost. And there we go. No more magnesium to be seen. And I need to get my final volume. And my final volume is 45.2. 45.2 milliliters. And as long as we're consistent with the way that we're reading this, that's what is most important. Reading it consistently. And there you have it. And now I will give you the barometric pressure, and you'll have all the values that you need in order to write up this lab and get your final answers. I'm looking here on my graphing calculator. I have a barometer probe, and the barometer probe will tell me what the surrounding pressure is. And it seems to be 88.54 kilopascal. 88.54 kilopascal. And there you have it. That was some fun. You know how much I love doing lab, and we get to do another one tomorrow. And I can't wait to see you then. Bye.